Okay, welcome back. This is Anesthesia 101 Online. I am your host, Siv. So today we're going to go over cerebral perfusion pressure. So what I've drawn on the board here, we'll go through this pretty quickly. You don't know, you can see this perfectly, but what I have drawn on the y-axis, I have the cerebral blood flow, which is measured in milliliters per 100 grams per minute. It's anywhere from 0 to 100. That's what we got measured here. And the x-axis, you have the cerebral perfusion pressure, which is measured in millimeters of mercury from 0 to 500. It's just numbers just to have a number up there. And we'll talk about these. So let's first things first. Let's talk about mean arterial pressure. Idealistically, for a normal person, you and I, we should be anywhere from 50 to 150. Other literature will say 60 to 160 or 70 to 130. So different literatures. The book I'm referencing right now for this material is from Stolting's Coexisting Diseases. I think it's a 2011 version, and Morgan McHale is what I'm using right now, and along with notes that I've acquired throughout the years. So let's dive right in. So when somebody's talking about autoregulation, the mean arterial pressure is where I've annotated here. So when they say they have some kind of central hypertension or vascular disease that gets shifted to the right, what that means is they're not normally the 50 to 150 anymore. They're going to get shifted either to 60 to, I don't know, 170 ranges, just for numbers' sake. That's trying to keep it as simple as possible. So when a surgeon asks you to lower the blood pressure and the mean arterial pressure drops below what's normal for them, so the reason that how you find that out is what the vital signs that you get in the pre-op area. It's what you'd be seeing as far as that's their baseline. So you want to keep that within that range, or anywhere from 20, no less than 20 millimeters of mercury that they're auto-regulated at. So that's what the mean arterial pressure is. Next, we'll talk about the PaCO2. You notice the PaCO2 as it rises and creeps up. Your mean arterial pressure creeps up. You ever had a case that you get a laparoscopic procedure done? You notice the instaflate CO2. As the CO2 goes up, your blood pressure goes up. That's the reason. You see why this goes up rapidly. And the other thing, let's go back to, I got off track a little bit. So with the cerebral blood flow and perfusion pressure, you notice that once the CO2 goes up, it tends to vasodilate. The reason your brain is vasodilating, it's autoregulated by the vascular smooth muscles that it's beyond this presentation. But anyhow, it gets vasodilated because your CO2 is so high. How the body gets rid of that, it vasodilates and rids it through your vascular system to get rid of your CO2. But that can only happen for only a certain amount of time. As the CO2 keeps creeping up, and you get anywhere from to this part where it's your mean arterial pressure is also creeping up. Your higher CO2, as I mentioned previously, that the higher your CO2 goes, the higher your mean arterial pressure is going to go. So it's only going to do it from here to here, and we're from 50 to 150 millimeters of mercury. At that point, so it's going to vasoconstrict. The reason why your cerebral vessel is vasoconstricting, that it has to protect the brain. It's smart enough to protect the brain. If it's going anywhere higher than 150 millimeters of mercury, you're going to basically hemorrhage. You're going to have a edema. You're going to blow your brain, basically what I'm saying. But that can only happen for a certain amount of time, and if you don't control that, you will have brain aneurysm. That's why you notice that the pressure shoots up, the cerebral blood perfusion pressure shoots up, and you no longer have cerebral blood flow as your CO2 goes up. And then lastly, we'll talk about the partial arterial pressure of oxygen. You notice that the partial arterial pressure of oxygen starts up very high as your cerebral perfusion pressure is at its lowest point. You get less CO2. Obviously, the blood flow is coming to your brain, give you oxygen. That's how your brain's getting oxygen. But as your cerebral perfusion pressure rises, it's all, like I said, same thing here. The autoregulation is going on with the PaO2, and then to a certain point above 150, it drops off quite rapidly, and basically you're calling the organ bank and the morgue. So little tidbits before I leave you. I don't want to make this too extended. Just my take on stuff. You can reference all this stuff on your textbooks from your review platforms that you guys are using. So I have what I have annotated in my notes is, so if CPP, as far as cerebral perfusion pressure, if there's a drop in your blood pressure, you have just to go over again, cerebral dilation. If there's a increase in your blood pressure, your cerebral blood vessels vasoconstrict to kind of protect yourself from having an aneurysm, basically. Little things that I picked up the long way, your cerebral blood flow and your cerebral metabolic rate goes up with the use of anesthetics like nitrous and ketamine. So just be aware of that. And I think we've done that already with the low mean arterial pressure, the cerebral artery vasodilates just to keep blood flowing. But the MAP goes up, the vasoconstricts, trying to protecting the brain. And lastly, the higher anesthetic gas or inhaled anesthetic, so your cerebral metabolic rate goes down because you're not using as much as to think. But at the same time, your cerebral blood flow goes up. Okay, so that's my little tidbit, real quick. Like I said, all this stuff can be referenced through your textbooks. Something I've picked along the way. I hope this helps. Comment, like, subscribe, and we'll see you next time. This is Anesthesia 101 online. I am your host, Civ. We'll see you next time.